I'm Charlie Clemmer. I'm a consulting system engineer with Aruba Networks. Just wanted to go through a session. It's kind of a segue or an extension, if you will, of what we listened to when we went with Chuck on the high density design. This is based off the high density design, the warehouse design VRD that we had done. I believe Chuck had it back around 2010 or so, and we've updated it a little bit with the release of the roaming VRD. So the VRD information is available on Aruba's website, but anyway, just wanted to go through a couple of different things. So first of all, some of it's kind of a summary, but I've got kind of what are the characteristics of a warehouse. We'll kind of cover that just as far as I know it's pretty self-evident, but some ways you may not have looked at it before, particularly if you don't work in a warehouse environment on a daily basis. Kind of going through some of the planning for it, some of the R fundamentals that we'll take into account from a warehouse perspective, and then just some basic troubleshooting. I've got a slide here for QA, but we can keep it interactive. If you've got questions, throw things at me, whatever kind of stuff, and we'll definitely go from there. There was already one request on Twitter to make sure everybody heckles me, so don't hold back. Anyway, so characteristics of a warehouse. A lot of different things. If we're used to working in wireless, we do, as the day job, kind of the office space or the classroom environment. We've got one set of challenges that, arguably you listen to some people, they'll tell you we can do it all predictive. I don't actually have to do a site survey, just throw the stuff up, stuff will work. Warehouse kind of throws a little different environment to it, kind of like the stadiums would, right? So probably the first thing that jumps out at me in a lot of places, a lot of the newer engineers kind of write it off that wireless in a warehouse is going to be pretty easy because it's all fairly low bandwidth. I'm not actually worried about a dorm environment. I'm not trying to stream Netflix out to a couple thousand users. I'm not trying to do these big graphics downloads or anything else. It's probably a telnet application off a handheld scanner that's just doing some quick polling back and forth to a mid-frame or a Unix computer somewhere at some other site, and how hard can that really be? And exactly that, it's the handheld scanners. It's stuck to a forklift, and it's probably on the same finance schedule that the forklift is, where they're going to amortize it out over 10, 15 years, and whatever you've got was what they got 10 years ago when they bought the forklift. We've got very high ceilings. You've got the shelving. We've got shelving can be moved around quite a bit. It's going to have various stock levels as we go through the season. If it's Christmas time, there may not be a lot of stock. If we're gearing up for Christmas, it may be stocked up more. And then we get into some of the hostile pieces as far as temperature, right? So if I'm dealing with a grocery store, I potentially have a deep freezer. I potentially have coolers. I've worked with a retail fashion chain that has an automated pick procedure type deal. So you've got all these conveyor belts and little electronic robots picking things up, moving them around. But it's not something that you would typically run into in an office, right? On the flip side, this is Dallas, or this is Austin, this is Texas. And so I could go from having that deep freezer where it's below freezing to being in an office environment or a warehouse environment where the ambient temperature is 105 degrees outside, and inside it's much warmer than that. So, we're trying to pull out both pieces of that. So on the physical side, if I'm dealing with metal shelving, yeah.
I just add real quick, you said there's low bandwidth requirements, but I'd say another critical variable is low latency requirements for the applications for productivity and user experience, because that is very impactful for labor expense.
Right.
And also low latency. I've heard some of the back-end systems do not tolerate any kind of latency.
What's been interesting is I've seen a lot of development because a lot of it will be telnet based, telnet proxy type things to keep the session alive back to the Unix host so that I can tolerate the timeouts. It all depends on what's in there, right? And most of the warehouses that I'm working with, it's not a net new build. They had something in there. I'll get into that in a little bit too, but it's we had 3 900 megahertz APs up when it was back, pre-standard stuff. So we did a one-for-one replacement, and this is going to work great. But a couple of different things, yeah.
And the other huge one is high availability, because downtime is deadly in the warehouse environment.
But it's interesting that different people have different takes on how critical that is. I mean, I agree with you, but then they'll turn around and do a frac T out to the site, and it's got minimal bandwidth, and there's no local compute. So if there's a fiber cut, then the site's just down. But,
Is there a reason for the low latency? It's introduced a lot of voice pickers now into warehousing. Things like voice devices for voice picking, and that's changing the ballgame.
Yeah, I'm hearing more of that, where I think the way the system will work on a forklift is there'll actually be voice instructions as far as where they need to go within the warehouse. So that continues to evolve. I haven't seen as much a requirement for the two-way kind of voice over IP. I'm not making phone calls, but I am using that type of application.
Yeah, they can issue voice commands and they get voice commands.
Okay.
And I saw recently, I was told in Troubleshooting, they introduced 100 voice pickers into a factory environment, and the entire site came to a standstill wirelessly.
Okay. Because they had, would you say like 100?
Design for that.
Right.
Basically,
Yep.
literally for the entire process sensor.
Well, good comments. You know, so getting back to the physical piece of that, you know, you've got from a layout perspective, I've got a lot of long aisles. I got a lot of metal shelving. What's stored on the shelves themselves can vary. It'll have its own RF characteristics. The flip side with the long aisles is I got to look at that as far as where am I going to place my APs? What type of antennas do I want to use? How are we going to design the coverage piece of it? And let's make sure, I think I've got it on here, it was on the last slide. A lot of times the configuration of the warehouse itself will change, either due to the seasonal loading, how they stock up, how they kind of work through the seasonal sales cycles. And I've had warehouses designed one way where we had rows running effectively, you know, east-west. You come back to fight a problem and find all the shelves are now running north-south, because for this time of year they re-rotated things. They're not carrying as much of one type of stock, so they reorganize things. And it's, if I did wall mount and tried to do directional antennas down a wall and they just changed all the rows on me, now I'm not pointing down walls anymore. The technical side was really trying to identify some of the problems that I've run into in my own experiences. So it's where we run into things like, I've got legacy APs out there. Let's just call it a BG access point. Somebody decided they were going to be really smart and use some high gain directional antennas. And oh look, I have an A and a B feed, so let me put one panel that way and one panel that way, and that's going to help me out, right? You know, and the second piece where I was talking about the forklifts and how they're amortized, a lot of times I still find guys that are running LEAP, or they only do WEP. The firmware or the hardware that they've got out there is so old they can't upgrade it to do something else. And so that ends up being a big piece of what we're running into. I do highlight it on another one, but one of the warehouses I was working on, they've got two sets of conflicting devices. One really wants to have 11K on, the other really won't work with 11K on. So what do? But those are the kind of things that we got to take into account as we're doing this. And then I think the comment on the voice picking service is kind of interesting too. A lot of the warehouses that I find, the guys that are working there, they're not just the typical hourly wage type of person like you'd run into at a McDonald's or something like that. They're paid based off of how quickly can they pick up an order, go get it, put it on the loading dock and get on to the next one. So how many orders did I fill in that hour versus I'm just getting a flat rate minimum wage type of thing. So planning for deployment, you know, a couple of different things that we'll dive into as far as, you know, what is the inventory, what is the devices that we expect to run on the network. If we're going into an existing warehouse, do they already have the scanners mounted on the forklift? Do they already have the handhelds that they're going to use? And if so, let's kind of look at what's the cheat sheet that I might use as far as what's most important to me. I'm really looking for things like what are my max output power, what's the authentication that I support. So this is where I come back and start to figure out things like, you know, do I need to have two SSIDs, one for WEP and one for somebody that hopefully is a little more secure. And then what are my radio types? I don't have any 11N or 11AC listed on here. I'm only just starting to see warehouses roll out to 11N type devices. And if you guys are seeing anything different, I'd appreciate the feedback. But so it's starting off with that. Let's find what's the lowest common denominator and build a strategy around how do I need to support that. And if it makes sense to go back and start building in two different sets of SSIDs or virtual networks, then we'll cover that. I also grabbed firmware revision. I've had problems where you might run into Motorola 9090s in one site and there's the same equipment somewhere else, but I'm running into LEAP issues and it turns out to be a firmware issue. So if I can keep track of what firmware we've got out there, then it gives me something else to, as I'm trying to narrow down problems, what I want to look into. But I'll grab it all in the planning stage up front. As far as the facility requirements, you know, the intended use is, again, kind of gets back to that, why a lot of people think it's easy to do. I'm just expecting to load data or somebody picking equipment or picking product. I'm not actually going out doing graphic file manipulation and that kind of stuff. But by the same token, when I worked at FedEx, we also had a lot of data centers hidden off inside warehouses, so I could have some alternative needs out there where it may be primarily a warehouse environment, but I also have office space out there. I've also got potentially architectural people out there doing their CAD work and whatnot. So we want to make sure that we understand what's being done out there. The other piece that was brought up was the high availability. I think Andrew brought that up. Do we have any kind of local links or redundant links from that perspective? What is the concern if we need to, do we need to be able to survive a WAN outage? By the same token, if I'm constrained on the WAN links, do I need to be putting radius servers out at the warehouse itself, or can I do .1x all the way across the network, assuming that I can, I've got devices that will support it? And then the other piece on the coverage area, I already mentioned freezers, but one of the things I've run into a lot is warehouses that kind of grow organically. So they started off as a 500,000 square foot facility, and then as it grew over time, they just keep adding on and adding on. And so now what used to be an exterior wall is an interior wall somewhere, but it's a great attenuator, it's a great reflector, and it doesn't allow my RF to go through because it was chicken wired and everything else. Yep?
Roaming through a firewall when devices go through can be a challenge.
Yeah.
The other thing that I've had found personal experience was shipping containers up to dock doors where they want to go into the shipping container with a device. You got to get signal down and into a shipping container.
When you have the bay with all the trucks and you got the forklifts trying to drop it all the way into the truck and they're keeping signal. So how do I go back and design for that? So it's catching those. In a lot of cases, that requirement won't come up until you actually talk to somebody. It won't be drawn on the floor plan. A lot of the old firewalls may not be drawn that way on the floor plan. They're just drawn as a typical wall, and it's not until you get out there and look at it that you realize this used to be an exterior wall.
You had like getting APs into freezers, because I've got that issue at the moment. It's obviously not cheap.
Yeah.
I have, and we'll get into kind of the recommendation on that in a little bit later. And then I'm curious to see if my way of doing it is the same as yours, but we'll get into that. So a lot of this piece is really focused on planning. So it's understanding, do we have the new application where I've got voice being read out to the forklift driver to tell them where to go pick up or what it is they need to pick up, where it's located in the warehouse. It's understanding then what is that minimum data rate that I need to design for. Go ahead.
I'm glad you're showing the slide, because back on the client stuff you were just talking about, where you showed the matrix down at the bottom. Mm-hmm. One of the important factors there is noting whether or not those older clients are able to support multi-data rates.
Or if I strip a data rate, do they freak out?
Well, yeah, because what we found here lately or recently is that the tendency is to disable lower data rates. Period. It's kind of standard practice. But when we start turning off the bottom of the data rates,
yep,
that sometimes disables the entire client. And then what we found is, that's looking at it from the controller or the WLAN down to the client. But some of the older clients have the ability to change the data rates at the client.
Sure.
Which allows it to work more efficiently and roam better and just get a better experience.
And we'll get into that too, but a lot of it, that's where you run into things like, I can set a roaming threshold. So, I'll roam when I see the signal difference is greater than 3 dB or whatever that is, right?
Right.
And then I have my other problem, which is the customer doesn't understand and puts a lot of APs and they power them all up to full power. And anywhere you stand, you hear 28 APs greater than neg 67. It's a fantastic design.
Yeah, they actually go out there, and after a well-designed network is in place, they will throw up extra APs.
Yep.
Thinking they've got coverage holes.
Yep. So the idea is really just, if we understand what the application is, if we understand what the minimum data rate is, not that we're going to design to the minimum, not data rate, the minimum signal strength, but I need to make sure that I at least know what that target is, so we can go back and design so that I can take into account that stock levels are going to change. I'm going to have different build outs on rack. I'm going to have to be mobile and move around and pass through that firewall or do whatever else. So I need to have that understanding so we can go back and know what my target is that I'm designing for.
You get the minimum SNR. Like I've rarely seen from any device besides voice over Wi-Fi handsets where 25 is the number that generally thrown out for SNR. Getting receive sensitivity is one thing.
Right.
And there's best practices, 20 dB for data or whatever. But I've never really seen for most other, warehouse or any other of these less common client types an actual SNR value. But do you see that from barcode scanner manufacturer?
Symbol's been the one that's been the most Motorola, as far as with some of the stadium stuff that I've done where they're doing ticket scanners, where they'll get into that kind of, I really need to see this.
They'll give a recommendation.
Right.
And if I guess if you've got other vendors that you have no other.
If I can't do an SNR, I'm still looking at power levels and make sure that we match up, and then trying to back in as much as we can. A lot of the information the customer's not even going to have in most cases, so it's a lot of, if I can visually eyeball the site and I can see how they're using the systems or they're using the applications that I'm concerned about, that kind of stuff, we can kind of put together a plan. The inventory list helps out quite a bit though, because once I start listing that out, either from experience, you understand, hey, the Motorola 9090, I need, to John's point, I really need to have, I can't turn off the 1 and 2 meg data rate unless I also go back and touch the device and say, hey, don't use those data rates. So you start to get that kind of consistency. And then the plus side is having it all documented, so when things change later, we can go through that. So, in this case, it's a little bit different from the high density design that Chuck was talking about earlier, but I think it's typically been a best practice, trying to match the client power back to the AP, so that I get away from that example I was using earlier where somebody goes back and says, well, I have a connectivity problem, my telnet session keeps timing out, so let me go throw another AP up and run it to full power. Particularly when we start getting into these racks, and I'm worried about, I've got some slides later that kind of illustrate the difference or the impact that a higher rack height can have the closer I get to the ceiling, what that does for my design or how that might impact my design. Making sure that we don't get in that area where I get a hidden node or I get that whole setup where, yeah, the client hears the AP great, so it doesn't think it needs to roam, and the AP can't hear the client for anything. So matching those data rates as best we can, and then running off the AP receive sensitivity. And then the other piece of this, from an antenna perspective, just gets back to the height at which the APs are mounted, and then it really doesn't matter what my rack layers or rack levels are set at as far as how high they get. In most cases, the APs are always going to hear themselves better than the client can hear the AP. And so it's how do I select the right antenna to make sure that I'm not using an RRM or an ARM, and the APs go, man, everything sounds great, let's get really quiet. I got to make sure that we're still able to see it. From Aruba's perspective, we recommend and use in most cases the down tilt omni antennas to try and still use a low gain antenna. I want to keep a small cell size where it's predictable, if it makes sense from an overhead perspective. But I'm focusing that energy down away from the other APs and trying to keep it more focused towards the clients.
Quick question, have you found that with integrated antennas that they work now? Because a lot of manufacturers like Aruba are doing them with some down tilt built in.
Yep.
Are those effective now in your estimation?
Yeah. And I've got a stadium story too, where you got the same things. You got the squinted APs up on the ceiling of like American Airlines Center that Chuck mentioned early. Actually being able to provide very good floor coverage, even though they're mounted way up there. But we were getting good coverage with it, and from a concessions perspective, that kind of stuff.
I did a survey a few weeks ago, and it was for replacing a wireless network in the factory, and it had the classic sort of factory, factory setup on the antennas hanging down. I surveyed it just with an integrated one with down tilt. I compared the two, the existing one there. The down tilt integrated antenna gave much better coverage than the external ones.
Okay. So this is the graphic I was referring to earlier that kind of goes through to illustrate then the difference or the impact that rack height can have. The closer the rack heights get to the ceiling, in the first model I'm trying to cover 2 rows on either side of the AP. When the rack height isn't very high, I can do that pretty effectively because I'm not going through as many obstacles trying to reach that end user the 3 rows over. As the racks themselves grow up higher, now I'm taking more attenuation as we go through, and it's kind of just the basic math on that. Kind of in general, some recommendations, and this I think gets back, Scott, is it? Yes. To the question, I think it was you had the question on the freezer piece. So typically from a best practice recommendation, we typically would do more overhead for just a general purpose kind of warehouse where it's my racks and overhead. When I get into freezer type environments, that's where I tend to do more wall mounted and directional and try to go down the row. Usually, and at least from my experience, what I'm running into is the freezer, and chime in if you have different, the freezer tends to be located where one wall of the freezer is an exterior wall for the warehouse as well. And so the customer has issues trying to penetrate that back wall. So what we've done in those cases is I may have like an AP134 from our perspective, an AP with external antennas outside the freezer, and then the antennas inside the freezer, directional shooting down the aisle. I may do a dual band antenna so that I can put a 174, an outdoor AP with a built-in heater at the far end that I mesh back to the 134, and it provides a 2-4 cell from that other end coming back.
So So you've got wireless backhaul, but you're still powering.
Right.
But you get power available already in the freezer.
Right. Yeah, we get power into the freezer, but at that point, that's all that I've got to get in there. We're teeing off whatever conduit was providing lights and that kind of stuff.
It depends on what kind of freezer. If you're talking, are you talking freestanding freezer?
No, I mean, you're talking like
freezer
freezer down an aisle, but I'm thinking more of a smaller, I guess more of a small retail freezer than a massive.
Yeah, because the massive ones in the warehouses, if it's a full cold storage, need an enclosure with a heater element.
Yeah.
The smaller ones. But if your experience has been as an AP outside with the antenna going in, the smaller freezers that are like,
as in a patch pointing in
closet size and, running in with some sort of patch or dipole.
But the antenna's mounted inside.
The antenna's inside, right?
Inside AP, outside.
Yeah.
We get what were the costs associated?
Not much, you just core drill through the freezer and then you fill it back up. For the small ones, for the larger ones, running low voltage cabling can be a tremendous cost. And usually you end up running a lot of extra low voltage cabling before you even install the APs in case you need them. So you run cabling everywhere.
Yeah.
You're doing it when you're putting in conduit and you're like, okay, I don't need extra cable. You never want to core drill for that again.
Or in my case, you're coming in to retrofit an existing freezer that didn't have it, so you're not getting in on the construction phase. So if I got to go back and do this, let's do it once and be done. And then the recommendation from our perspective, I think, kind of echoes some other experience as far as having the down tilt Omni anytime I've got ceilings over 25 feet. So the idea, yep. I'll just say the idea being is the ceilings get higher. If the ceiling isn't high, if it's a typical office space kind of environment, then down tilt may be negligibly effective. But when I start getting much higher, then having that down tilt where I'm focusing the energy down between the racks instead of across the ceiling to the other APs.
Any thoughts on like techniques for doing surveys for these tall ceilings? A forklift and a real long batch cable.
Exactly.
Yeah.
What's that?
Battery units, the Tesco battery units. So
Yeah.
Put the battery unit on the highest rack that you can so the forks can still go, and get yourselves just some beam clamps or something that you can make a mounting bracket so you actually hang your AP units and go, and then you don't block any fork traffic as you're doing your survey. Get a lift.
And OSHA's totally okay with this, right?
Who's OSHA? It's only there for 20 minutes, right?
Yeah.
It falls, just run. You can do a safety chain, yeah, John.
Yeah.
Just one other comment, I don't know if you're going to mention multi-path or freezer or not. We're going to cover that at all.
No, I wasn't. Usually from what I'm running into is I have that same problem where I've got legacy clients that really don't handle multipath to begin with. And then, yeah, in the freezer, the freezer would be prone to multipath, but a lot of times the stock that I have in there is going to be more absorptive than reflective.
And so I would say that it's very critical that you don't test the Wi-Fi until there's product in the shelving.
Yes.
Because a lot of people test it and then it looks great, or they put product in there and it's horrible, or you run into multipath issues in one scenario but not the other. And so, just from experience, test a live condition in the warehouse.
Well, and then keep in mind, and I do at that point later, even when you do the test, you do a site survey or you do a post-install validation. That test is good for that one point in time. So as soon as you're done, 30 minutes later, that forklift comes through and loads up on all the stuff that Blake just bought off of Amazon and takes it out, and the conditions change, right? So.
From the perspective of predictive versus on-site, obviously it's still a contentious topic. My thoughts are sort of follow what Keith does, which is sort of what I call an enhanced predictive, where you're on-site, all of those things you can't get off-site. But where it falls apart for me, that method of taking wall attenuation measurements on site, putting them into air magnet, and you've got real values, and you can see the ceiling, you can see everything, but in a warehouse, you can't really take a wall attenuation value because it's not a wall, and are you getting real values, and again, the stock on the shelf. So what are your thoughts on using predictive?
So I'm still very big on actually doing a physical, whatever you want to call it. It may not be called a survey, but I need to visually eyeball the site. I want to look for things like the firewall that used to be an exterior wall that's now an interior wall, or a true firewall that may not show up on the floor plan. I need to see where the freezer's located, how things are laid out, the rest of that. So I'm looking for that, and I'm wanting to find anything that jumps out at me as something that I need to investigate further. So if I need to go back and try and take some measurements, I can do that beforehand. On the flip side, again, it's one of those where you've got to do the post-install validation to say, here was our design requirements, this is what we were going for, did I actually achieve it? So with the stock levels as they are, or as we expect them to be, you know, and again, to Andrew's point, I don't want to go back and do a site survey or a post-install survey and say, yeah, everything looks great. Now let's bring the racks in and start loading the stuff up with stock. So it's you know, how do we go back and set that to keep?
I mean, so you're on site then, but are you taking any measurements at all, or just, you know, if it's the odd part of the warehouse where you think, well, I really need to measure that to get a real...
So I'm not usually on the pre-install. I'm probably not doing a lot of surveying unless I see things that jump out at me as something that needs to be looked at. So I'm going to spot focus it more.
How do you take into account attenuation of racks and get any sort of realistic value?
You can spot check. I mean, we say
Yeah,
a low-cost alternative to going out and doing an active survey or live survey on that site is we send like a junior engineer out to do a spot check, see at that point in time what the percentage of fill is on the racks.
Yeah.
Then we'll bring that data back, and then we'll either gen up a CAD file or mock up a file that we can load into a predictive planner, and then attenuate those areas.
And that's what I was getting at with what I mentioned,
Right.
Keith's sort of method of taking wall measurements and putting real values. You're saying do the same thing. You've got 20 racks, we'll just measure 1 or 2, and then you've got some sort of real data to put into it.
So I'm looking.
Loop up there, and plan it properly, and then if you got to make adjustments on the fly when you do the install, you do it.
Right. So I'm looking for. Typically in the warehouse, you'll find that it lays out, you know, here's where they keep all the if it's a grocery store type of thing, here's everything that goes in the pharmacy department, here's everything that goes in the dog food, cat food aisle, here's everything that goes in the, you know, the produce areas. So if I can find those areas and kind of do some spot pieces to figure out what's their stock level, those kind of things. It'd be similar, and you pointed it out on the high density stadium design when we start talking about concrete. So one of the things we'll do there as well is if I'm going into an existing stadium, I may do some spot surveys to see, well, what is my loss through this concrete? How is the concrete? What's the water content? That kind of stuff. So very similar.
It's a good middle ground, in my opinion, of cost and time, and still getting some accurate.
Yep. All right. So, you know, this kind of gets into part of what we were talking about. We've got two different sets of RF characteristics about any of the product that's stored in the warehouse, right? It's either going to be resorptive, reflective, combination of both. And part of it is that I'm trying to figure out then is which is it? So am I dealing with a manufacturer that makes outdoor, you know, multi-ton HVAC equipment, which is all metal and freon, or am I dealing with the pet store warehouse where it's all bags of dog food, that kind of stuff? I'll use that information to cater or tailor what I might be using for attenuation when I'm doing a predictive plan. You know, this is one of the slides that Chuck has used many times and usually caveats it with the whole, you know, do this test at your own risk. If you really want to see how absorptive it is, put it in the microwave, nuke it for a minute, put your hand on it, see how hot it is, and don't be by it when it explodes. But just kind of some ballpark then, as far as if I'm looking at things on the shelves and trying to get an idea for, is this going to be a big absorptive? Am I going to take a lot of loss off of it, or is it going to be not so bad? It's kind of categorizing them as it, you know, small, medium, large on the absorptive side. Is it reflective? And overall, I've got more issues with absorptive products that are going to attenuate it more than I do on the reflective product. Let's see. Yeah, and then this was just kind of basic. It's you know, most warehouses are going to carry a mix of different products, so it's how do I go back and do the predictive, and I want to take that into account when I do the other piece as well, which is the post-install validation. The last piece here that I'll get into is we'll start talking more. I had the first couple slides talking about what are the coverage characteristics I need, what's my minimum SNR, those kind of things. I need to have that identified so I know kind of where my drop dead target is, but then we get into what is reliable coverage or coverage reliability, which is making sure that I can actually go back and hit those metrics once the stock's up or if we load up with more than what I expected.
We get a lot of problems in data centers, which is similar to the warehouse in terms of big space and a lot of metal. Because a lot of roaming, kind of unequal power, like the equipment here at the client.
Okay.
We end up disabling the micro and these are very reversing. So
Okay. I have had one warehouse, and I'm drawing a blank on the client that they were using, but it really didn't like when we were set up for MIMO. So even though I've got 11 NAPs on there, we set them down to to basically just act as a legacy AP, and that solved the connectivity issues. But again, a lot of times it's not just one issue, it's looking at everything that's going on. We also had that people constantly raising power. I get more into hidden node type stuff, and so how do I go back and correct that as well as deal with any of the PHY issues that the client has? Matthew hit on this earlier, because dB is a logarithmic scale, and I know we're all aware that small changes can make a big difference. It's that, can I get the 1 decibel of salary increase? So the idea is still anything that we can change, down to tweaking if it's 1 dB on AP power setting, or where I move that AP and I gain a dB off of it. It's those type of changes that we want to look at, how things are deployed, where are we at, and making sure that we're good. I've already hit on that last bullet there as far as the typical site survey is as good as that one snapshot in time. Things are going to change, and we need to be prepared for that. So the coverage reliability piece really gets around to designing to make sure we can reach that. If I have a requirement then effectively that says I need to provide an SNR of 6, not doing the voice app, but just doing a basic kind of telnet thing, then I really need to be designing that I've got something better than that, right? So as stock levels change, hey, if I'm designing and I know I could always go out and do a site survey and show that I'm getting, what did I say my example was? I needed 6. So if I'm always out there getting 9 or getting something better than that, then I'm good. But if I go out there and survey and I'm getting exactly 6, then I've designed something wrong. I've met the requirement, but I don't have that reliability piece factored in. I'm going to jump through this slide pretty quick, just kind of getting into some, Chuck mentioned the elevation diagrams that they actually do exist. Just to try and illustrate here a little bit around why when we get into the high ceilings, I don't want to do, high gain antennas mounted up on the ceiling. Directionals off a wall would be a little bit different, but even the low gain true Omni versus something like my down tilt Omni, trying to make sure that I don't have, or I'm minimizing my AP to AP interference, or adjacent co-channel interference, those kind of things, so that we get as much signal down where the users are, where we've got that focused, while minimizing any of the negative side effects. The next 2 pictures here, this go back to if I do a wall mounted, and a lot of the questions that I get will come back with, hey, let's just do a high gain, instead of trying to put a bunch of ceiling mounted Omnis, I'll do a high gain directional down off the wall, shoot it down the aisle, and go from there. This is showing 2 different antennas. One's a 13 dBi, one's a 5 dBi. And while the 5 dBi gets me a little more than halfway down the aisle, and if I came the other way on the other side with the same antenna to come back and fill it in, what shows up better here on the next slide is by doing that, I end up with a pretty big shadow underneath where that antenna is mounted, right? So it's great. It can go all the way down the aisle, but as that forklift comes out and then turns to go back to the loading dock, I've got a great big RF shadow where I don't get good coverage at all, if I get coverage. So I start to run into those roaming issues, those kind of things. It's from a roaming algorithm on the legacy client, I got great signal, I'm getting better signal, and then I get in that shadow and the signal just drops off, and all my antennas were mounted along that wall. That would be a bad thing.
Is it likely to be a point where you could get enough mechanical downtime, I guess, to get enough mechanical downtime to cover that, you've got to compromise the other end?
I think it ultimately depends on what's the length of the aisle, right? Because potentially you could, but at some point, yeah, you end up, you're down tilting mechanically the antenna so I'm losing my long range to fill in that shorter. Whereas if I just gone with the 5 dBi or something with a wider beam width, I still cover half the aisle, and I get good coverage up there, and it kind of get both. Typically using Ethernet rather than wireless. I'm not usually running mesh on my warehouse APs. That's kind of a whole nother conversation point then, is where can I put IDFs, and I've had some interesting IDFs suspended from the ceiling and that kind of stuff. But yeah, usually it's typically doing copper so that I can do PoE out to the devices if I can manage the IDF appropriately, and that way I get all those benefits, right, if I need to reboot an AP or whatever. I don't have too many people that have actually looked at running fiber inside of a warehouse for that. So, again, from an antenna's perspective, if it's mostly vertical coverage, if it's not the freezer, I'm typically looking for a high ceiling, a low gain down tilt Omni. And I think we pretty much already covered the reasons why there. So from a troubleshooting perspective, another one of the things I figured I'd lead off with is one of those things that Keith likes to bring up repeatedly, right? What is the problem that we're going on or that's being reported? A lot of times it gets reported as the wireless is down, the wireless sucks, the internet's down, the internet sucks, you know, whatever. You get into it and find out, well, I'm not getting something like a basic DHCP. I'm not getting an IP address. The RF is fine, but I had a helper that got misconfigured or something along those lines, right? So it's knowing the questions to ask to try and fine tune from the end user who's not technical, he drives a forklift. What's actually going on? What is he experiencing, and how can I step him through what's going on out there? So part of it's digging into what's the actual workflow or the problem flow. Is the client actually able to associate to the access point? Are we able to authenticate? This gets back to an example that I had where, again, a low bandwidth WAN link. My radius server was all the way back in Texas. The warehouse is all the way out in California. They constantly were oversubscribing the line and not prioritizing EAP traffic, so my .1x would time out and fail, and they added more APs and boosted the power up. You know, is the problem just when the client's stationary or roaming? And that gets back to, if I understand kind of how the building's laid out, you know, looking for things like that firewall that we didn't know about or those things. SNR between the client and the AP, looking at that both ways, not just how's the AP hearing the client or how's the client hearing the AP, but both sides. Do I have an asymmetric deal where the client's hearing the AP great, but I can't hear the client? Did any other network events occur? And that gets back to that California, Texas story, right? So when we had the WAN link being overutilized and dropping EAP traffic, the wireless team was unaware that that was going on, and would have been a good clue to have up front when we were troubleshooting that. As far as on the roaming issue side, again, kind of looking at consistent power level, this comes up several times when we maybe did do the initial install, did our post-install validation, and verify that everything was set on the right power level, but over time, people tweak things, people are trying to work on why is there a problem, those kind of things. Or we had an AP go bad and somebody made an AP, put it up there, and it ended up not configured the same. So just kind of validating that we're on the right power setting, that clients are able to hear. I mentioned the second from the bottom here before. Some clients are very particular about 11K, and I've seen it both ways, where some clients won't connect if it's enabled and other clients won't roam unless it is enabled. And then it's just kind of understanding up front what's our client behavior and what's expected for them.
What is it about 11K that would trigger that? That seems like a weird. It's the client's responsible to send neighbor reports, so just having it enabled is just one more information element.
That was a implementation issue.
I think it ended up being it was more of a compatibility issue where so they were supposed to send the neighbor reports, but what I was also seeing off of it was the client would turn around and start running at lower power. So we had our APs, but they would run lower power, so then they couldn't talk back to the AP to associate. So the end user's experience was, I've got coverage holes all over the warehouse. And when we turned on 11K, the client side actually started using a better power selection decision.
Remember back to the 802.11n, when we were first trying to do that, you had all those additional informational elements in there that was pissing a lot of drivers off.
Well, and I think that's why, you know,
It's just what happens. You get all these new IDs going on there. Like we said, if they don't have a newer driver, if it's an old driver.
if it's a handheld that was built in 2005 and still only does weapon TKIP, then.
Like there used to be issues with the country information.
Right. Yeah. Uh-huh.
I had a lot of success in the roaming troubleshooting actually to do the disasters of actually do not changing the vendor or anything, but doing one channel over. Because I found a lot of the legacy clients, they were like hundreds of milliseconds of just tuning the radio. Way too low, too slow. So just doing one channel, we have no throughput, but we don't need throughput sometimes.
Okay.
It worked really well. That's one thing I did, and the huge output deployment, I did like an external client bridges, because the internal card has really bad algorithm sometimes, the roaming and so forth.
Sure.
So selecting like some other vendor output bridge to put on the truck that you can tweak all sort of settings on, that's also very helpful.
Okay. Yeah, so I'd be curious on your first example. I've seen the opposite problem where, is the end user decides to go put up more APs and increase power, that kind of stuff. They were very proud that they could stand anywhere in the warehouse and see 28 APs greater than x67. And so the problem was this old device, as it would go out and scan, would keep the top 5 or 6, whatever it was, and drop all the rest. So as it's scanning, it would pick whatever the first 5 that responded back and would not put in that table the better AP that was closer because it took longer to respond for whatever reason. So there's different sides to that. But yeah, I mean, sometimes it's from a troubleshooting perspective, if it's something new or it's a new client that's being introduced, I may go back and add a new SSID or something to where I can go back and tweak just that environment without messing the rest of the production stuff. And it's trying to understand or monitor what that client behavior is. Know the client, right?
Well, I'm curious what your recommendation now is on APs across controllers or on the same controller, because back in the day, it used to always be the recommendation of put all APs on the same controller, even if you have a backup controller. Don't roam between controllers. Is that still your recommendation, or has that improved in your experience?
I'm a keep it simple person, so I would keep them all on the same controller. I'm minimizing what all's going on, right? I've got other HA mechanisms so I can handle the failover if I needed a failover from another controller. Warehouse setting, I may do something controllerless, not have a physical controller there at all. So, yeah, I would prefer not to introduce, and typically the warehouses I've got aren't large enough to where I wouldn't be driven from a capacity perspective to need 2 controllers. So the other one's from a redundancy perspective, and we'll just minimize the number of things that can go wrong by keeping everything on one controller. I do the same thing in stadiums too, for that matter. Troubleshooting installation, I've already talked about a lot of these as far as the AP power, antennas, that kind of stuff. The one thing that does come up more and more though is the new services like the voice activated piece for talking to drivers. You start to see more new services that get introduced that may be Bluetooth enabled, that may be frequency hopping, that may be video surveillance cameras, etc. That's typically one of the things. If you had a warehouse that was working fine, it's been installed, it's been good for a number of years, we kind of eyeball, we know the racks didn't move, changed, that kind of stuff. From the previous session, if I get a spectrum analyzer out and can see if we get traffic out there that's wasn't there before, it gives me a clue on what to look for.
Yeah, I would still add that list in the roaming list. Before that, I would still add check data rates.
Yeah.
I mean, that bites so many people from an engineer standpoint and a customer standpoint.
Sure.
If the customer's installing it, it's natural inclination to disable lower data rates. Forgetting about that.
I don't have that. I don't have that customer. They leave all the low data rates on.
The last time you updated the driver, the last legitimate update to the drivers occurred 7 years ago.
Right.
So
Or if I'm retrofitting, I can go put my APs in there, but I can't go touch all those. So I still need to support Leap. I still need to do something else along those lines. So it's validating what we've got.
Yeah. Say Leap.
Yeah.
Something that can grow. Keith said we could do that. And the client.
I still have clients that want to run Leap. They'll acknowledge that I know it's no good. I shouldn't do it, but to actually touch all these handhelds, you know how much money that would cost?
Mm-hmm. I work for a mobile manufacturer, and Leap is a 4-letter word, but it's very, very prevalent, and everybody's heart attack. Whereas if it was up to me, yes, it'd be all on, but they're like, handhelds are so much money, we don't have the budget, we don't have the handheld. Now, we could get rid of the handhelds, but then we're going to have to cut somebody. What they say, maybe you.
I've had the other scenario, which is, so we keep failing audits because I have Leap. So let's go do an ACT deployment so I can at least make sure the device that's using Leap is valid.
Yeah, I mean, Leap and weapon is, it's the business case. The business types don't understand that they need to get this done. They want to squeeze every penny out.
It's got to come from a compliance or a security.
Another thing that we hear a lot is there's a bunch of warehouses around the country, multi-million square foot warehouses that store automotive parts. But
right.
The argument going on is they want to survey one place and then cookie cutter to every other place. And I said, it's not so much.
Right.
Every building is different. I mean, there's going to be some similarities. I'm kind of losing that argument.
Yeah. Andrew?
Real quick, I just want to touch on one thing that's worked really well for me in freezers and coolers when I've been in there is sometimes some freezers and coolers can have a ton of multi-path. And sometimes you're running way too hot.
Right.
You might need to shut off radios. You might need to turn down power. The other thing I found really effective is remember back to John's point, data rates. The lower data rates have better error correction. I found by turning off the high data rates, even though clients could use it because the signal strength is high, going with just the low data rates, their connection is way more stable sometimes.
Okay.
It kind of goes back to the point of disabling and enabling, but you're saying even to a lower degree.
I've left it with 1 and 2 and like 6 and 12, and that's it.
But the problem there is stickiness. Because then that client comes out of the freezer and goes clear across the warehouse, and he's stuck to the back lobe of that directional that was shooting inside that freezer, or whatever the deal was. So you got to be.
It gets back to understanding your traffic patterns too. If that device can do that, I need to look at that. Then maybe it's better to turn power down or do something else. If I've got a separate set of scanners that stay in the freezer, use that trick. Go use your middle data rates to keep him stable, and then use upper data rates the rest of the warehouse.
It's also good to know your device, because each device is going to behave in different ways.
Well, and that's where I get back to your point on trying to cookie cutter. The more documentation I have as you building them out, either to show similarities or to show differences, kind of goes back to drive your, well, here's why I need to go out and survey things, because we don't use the same Motorola 9090 with version 1.74 of firmware.
Add documentation of the, I mean, that's assuming we can get it. And,
right. Yeah, sure.
Kind of back to that argument with an older device, it's too cost prohibitive because it doesn't support anything beyond, say, Leap. Or, have you had any experience with devices like a newer bridge type device? It's a pretty solid device with support 802.1x, something along those lines. It's low power, portable. I mean, not to bridge to that kind of device exactly, but maybe other portable devices where it just comes with some old card, the vendor's not willing to move, but you need some way you want to attach it. You want to be able to support the device. A wireless connection. Something that would support better encryption, the 802.1x standard.
But since you said bridge, some sort of repeater or something that the legacy device would connect to, and then use.
It would interface in some way, not wirelessly necessarily, but Ethernet or serial. I've seen some serial products, but
I've run old Thomas A pieces, worker fridges, and back in Ethernet onto some, like a printer or something like that.
Yeah, the problem with that is just the battery, the power requirement. I mean, some of these devices we want to support, they're just not going to bolt on some huge battery to it. It's just a small little card.
Yeah, and that's usually what and that's usually what I'm looking at more. I haven't. Usually what it ends up being is, here's how the install needs to be compromised, or here's the trade-offs that I'm going to do, and we're all aware of it. But so I need to end up with 2 SSIDs because I got these devices that I have to support, and they're only WEP or TKIP or whatever. So we'll put them over here, and these other devices, they support newer standards. They can do whatever, so we'll put them on a different SSID.
So now you said another SSID. I've got to
No. But I'm not suggesting that we get out and start doing 5, 6, 7, 8 SSIDs either. If we've got 3, I don't want to be there, but okay. It's if I got to go out and start doing, when it gets crazy, that's when I'm not doing it. But did you even?
About troubleshooting is your baseline of what's good in a warehouse can look completely different than what is in an office or any other.
Oh, sure.
So just understand that 10 or 20% retransmission might be okay in a warehouse environment because that might be the baseline.
Yep.
That's what it is.
Well, and to add on that, just because a warehouse comes back and says I need to support carpeted office applications doesn't mean I have to go build out the entire warehouse to do that. Keep those applications or keep that density in the carpeted space and do your roaming application for the rest of the warehouse. Yep.
So is there ever any value like predictive designs in warehouses when it's 3D all the way? So anybody use like predictive tools for warehouses?
Yeah.
And it works? Okay.
Well, I think the comment, I was getting at this earlier, and it was that, and my feeling is that there's a nice middle ground between predictive and a full on-site survey, which is doing predictive but having some real measurements, so not spending a week doing a survey, maybe not at a warehouse, but at a hospital or whatever.
Yep.
Spending a day getting some real measurements, looking at the real measurements at the site, and then putting that data into a predictive.
I think in predictive, when I say predictive, it always is real-world measurements, real attenuation measurements, or rapid attenuation measurements, or well, you should be taking attenuation measurements, and to say, unless it's a building that's not being built, you'll survey, that's the only exception. If you're doing a site survey, and you're not doing spectral analysis, then your site survey is pretty worthless. Anyway, so you've got to be on site to do some threat analysis, and take the attenuation measurements, put that into your predictive planning, make it a lot more accurate.
The biggest challenge,
I don't care to say, but
the biggest challenge that probably many of us have is that we don't write. It's a pre-sales guy who knows nothing of wireless, or it's a sale. It's just some guy that has sales in his title. Like, you don't have necessarily that control, so they just think you can knock out. You know, the APs have been bought. Do a predictive survey now. We want to roll them out tomorrow. So that's the biggest challenge for me. It's not knowing how to do that. It's getting those guys on board. Or you against the rest of the team.
you have to make measurements.
Yeah, or the customer just thinks they're being fiscally responsible and said, well, I had 3 900 megahertz APs in here before from 15 years ago, so we'll just do a 1-for-1 replacement and I'll throw in 2 extra and that's got to be better, right?
I think that's where what I was
Yeah.
I think that's where what I was getting at is a good compromise as well, because you can say to the customer, we're not saying that you need to spend a week or 2 doing a survey. That data you get from that 1 day or 2 days is valuable. So it's a nice middle ground. It's a lot cheaper, but it's still, you've got to get a good result.
Yep, and if we've done the work up front to identify the clients, that kind of stuff, so that I've got an idea of this client's going to cause problems, this one's not, we stamp out those issues before we ever get installed, and we're better off. Yes, sorry.
The flip side of that, of being on site to do a predictive analysis or whatever you're going to do, is what we run into a lot. We run into in the clients that say, I want a ballpark budget of what this thing's going to cost before I'm going to pay anybody to come on site, so I want a heat map, I want a predictive analysis. And then you get a lot of that stuff answered up front. What are your walls made of? How thick are they? Where are they at? Do they go floor to ceiling? Are they firewalls? Do you have to sleeve and seal these freezers if we go inside the freezer? You get all that stuff up front and you do the best you possibly can, being conservative, knowing that after a survey is done, more than likely the number of APs you're actually going to have to deploy is going to come down by a few. So you set the bar just a little higher than you actually think it's going to be, just to give them some kind of budgetary dollar value to give it a go.
Well, that's why we came up with the name ROM, right? It's a rough order of magnitude. It's not supposed to be a bill of materials. It's
Yeah, but I'd push back on it. So that's a level goal, but the behavior I actually observe in the field is, and frankly, one of the most dangerous things I see customers do to themselves is this trend of essentially requiring a vendor to submit a predictive design as part of an RFQ response. That is insane, right? Because what incentive do you have as a vendor to do a complete job if you don't know you're going to win the business, right? So you're going to do the least amount of work you can, provide. You'll give a complete response, but you're not going to even if you do, you're going to take minimal measurement of your on-site per day. I think this is one of the least self-serving, least responsible decisions that customer IT organizations can make. You select the vendor, then you bring in a consultant. Or you bring in a consultant first, and you pay the money. You get a proper design.
Before the RFP, before you're ready.
But because the flip side of that, I've had the RFP where you had to do the predictive survey and you don't actually get to go visit the site. Here's our floor plans.
Yeah.
So
This is, I've been away from warehouses for a year and a half or so, working on stadiums, but this is common in stadiums now. It just blows the
Yeah, you can't do it.
And it's been standard in hospitals.
but the expectation's been set, right?
Right.
So
This is not serious. So the customer, what they want is not changing. They want to know how much, what this thing's going to look like, so they can figure it out.
But in fairness, on the flip side of that, I agree. If you're forced to do that, that's wrong. You have to push back. But on the flip side, we've actually won deals where we've taken and said, okay, this is 75%, 80%, 90% accurate. Here's a prediction. And just did that little extra work to get the deal. Then we get it, but it's in a rough order of magnitude format. It's not this is an exact science, this is a rough order.
Well, so I'm talking about RFPs where the vendor, it's something like now, where the vendor has to guarantee the performance of the system.
right.
Well, we see that a lot.
With off of just floor plans, and that's
You're assuming that you can ask all the right questions, but if your factory's in Thailand and you're in Dearborn, and you're asked, and you don't get the right answers, and then what are the walls made of? What is this? What is this? And they give you answers. And
Yeah, I never got the right answers dealing that long a distance.
What questions you ask, it's the quality of your information.
Yep.
I would say. I mean, it's like That's my biggest pain right now. Is handouts, containers, and warehouse things.
Yeah. The things you can't control, even with a great RF network.
I'm doing is pretty good.
Yep.
And that communication is really important, like even in other networks like VoIP, what an end user might call you drop a call, and
right.
what the voice engineer will call a drop a call are two very, very different things. So sometimes it is tough when you have that kind of separation, language barriers, things like that. Well, I dropped the call. It's like, oh, well, and that doesn't mean the same thing to the same people. So sometimes you can't get away without going on site.
Yeah, and then you ask forklift driver this and this, they're just,
yeah.
It doesn't work.
The forklift driver is probably the wrong guy to talk to. But I'm running out of time, so we'll take, sure, one more question. Andrew.
Well, I was just going to say that in NMS, like your guys' airwave, but historical
right.
visibility in the client state is tremendous. Because the last thing you want to do in a warehouse is say, okay, can you get on a call while you're out on the forklift and tell me when it happens?
Yep.
Been there, done that. That sucks. Don't do it. Avoid it if you can.
Common practice all the time.
Yeah, but when you're on the phone with him, it won't drop right there. It'll drop some other place, and then your data is all skewed. I hope this was useful for everybody. And any questions that come up, you can tag any of us afterwards, and be happy to talk. Thank you.